Good afternoon, everyone. Today we will discuss a new unit, that is the unit of curves. So in this unit, we will discuss about the various types of curves which are used in highways and railways. So basically, the curves are of two types. So one is called horizontal curves, and the other one is called your vertical curves. Horizontal curves are provided in the horizontal plane, and vertical curves are provided in vertical plane. So all those curves which are provided in hilly areas, these are called your vertical curves. So first of all, we will discuss what are the various types of horizontal curves. Then we will go in the last, we will discuss about the vertical curves. Okay. So let us start with the definition of curves. Curves are defined as arcs with some finite radius. So whenever we are discussing the curves, it means it is an arc with some radius provided between intersecting states. State means either these are the straight roads, okay, to gradually negotiate a change in direction. Whenever we want to change our direction of motion, okay, we are suppose that we are traveling on one straight road and we want to change our direction. So whenever there is a change in direction, we have to provide curves. So this change in direction of the straights may be either in a horizontal plane or in the vertical. Okay. If the direction is in the horizontal plane, change in direction in the horizontal plane, then we call it as horizontal curve. If the change in direction is in the vertical plane, we call it as vertical curves. So all those curves which are provided in our locality, okay, because these are change in direction in the horizontal plane, so those are all your horizontal curves. When we go to the hilly areas or mountainous regions where the change in direction will be in the vertical plane, then all such curves in those areas are called vertical curves. Now these curves are generally used on highways or railways where it is necessary to change the direction of motion. Now a curve may be either of circular shape or a parabolic shape or a spiral shape. Now it is not always necessary that the arc which we are discussing here having that is your circular in nature. That may be circular, means a constant radius. We have sometime we have parabolic. Okay, this arc is a parabolic in nature or sometimes a spiral in nature. So let us come to the classification of the curves. First, we call it as horizontal curves, as I discussed. If it is in the horizontal plane, we call it as horizontal curves. If it is in the vertical plane, we call it as vertical curves. Horizontal curves are further classified into the following types. Number one is your circular curves. Okay. And number two is your non-circular curves. Here the arc is a part of a circle. So if it is a part of a circle, we call it a circular curve, means constant radius curves. Okay. And we have some non-circular curves. So non-circular curves is called transition curves. In these type of curves, the radius is not constant. Okay. So that's why it is called non-circular curves. The name which is used in the surveying for those curves is called your transition curves. So basically, if you see the classification of the horizontal, we call it as broadly, it is circular and the non-circular. So first of all, let us discuss the classification of circular types. So these are divided into three types. Number one is your simple circular curve. Number two is your compound curve. And number three is your reverse curves. So we'll discuss one by one what is the meaning of these three types. Okay. So let us start with the simple circular curve. Simple circular curve means a curve which consisting of only a single arc. So we have only a single arc here, okay, with constant radius. Radius is R, 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 okay. So we have a single arc connecting two states. So this is my straight road, okay. If you are extending this in the backward direction, so this is my straight road. I'm coming from in this direction, okay. And the other straight road is in this one, okay. So when these two straight roads, okay, they are extending, so they are intersecting at this point, okay. So this is the starting point of the curve where I want to change my direction. I was traveling from here, and then I want to change my direction. So I have to introduce a curve here, okay, that have a constant radius. So this curve is called simple circular curve. Means a curve which consists of only one arc or single arc. Clear? Now second one is your compound curve. Compound, as the name suggests here, means it consists of two or more arcs. Two or more arcs of different radii deflecting in the same direction and lying on the same side of common tangent. Suppose that this is my one straight road here and this is my another straight road here, okay, and we have a one arc here from here to here having a radius r1 here, and this is my another arc having the radius r2. So this is my center of the first arc, that is your O1, and this is the center of the second arc, that is your R2. Okay, the center is O2. So if any curve which consisting of two or more arcs of different radii, okay, but they are deflecting in the same direction, and they are at this point where the two arcs meet, okay. So if you draw a tangent line here, okay, at the 2 points where the two arcs are meeting here, so this line is called your common tangent. The line ATB is called your common tangent. Clear? So a compound curve means a curve which consisting of two or more arcs with their centers on the same side of common tangents. This is my common tangent, and both the centers are on the same side. So this type of curve is called your compound curve. We have another type of curve that is called your reverse curve. Reverse curve means a curve which consists of two circular arcs of same or different radii having their centers on the opposite side of common tangent. Now this is my one curve here. Okay, this is my one curve. The second curve is this one. Clear? So you will see that now here this is my common tangent. If I draw a line here, this is my common tangent line. So a reverse curve is a curve which consisting of two arcs. This is one arc, this is another arc, with their centers on the opposite side of common tangent. My common tangent is here, the one center is here, one center is here. Okay, so such type of curve is called your reverse curve. Yeah, and it is also called S-shaped curve because the shape here it is S. Look here, I'm starting from here and then going this way like this. So this is your S shape. Okay, serpentine curve or S-shaped curve. So these curves are commonly provided in railway yards. Railway yard means where the trains are parked for cleaning purposes, for maintenance purposes, not on the main track, but towards one side of any station, okay, where the rails are parked for maintenance purposes. So these are called railway yards. So this type of curve is provided in railway yards, but are unsuitable for modern railways. It is not suitable for main lines. Okay, these curves are known as serpentine curve or S curve. So as I told you, this is your S shape. So it is either called S curve or serpentine curve because of their shape. Now come to the parts of a circle. Here you will see a diagram here, where there are so many things are written here. So I just explain one by one. Okay, so these are called your elements or the parts of a simple circle. Okay, so let us first that is called your back tangent. Okay, what is the meaning of this back tangent? Now suppose that this is my initially the straight road. I am coming from here. This is my straight road. Okay, and this is my another straight road in this direction. So I have to provide a curve between this point and this point, as I want to change the direction of motion. So what is my back tangent? Back tangent is the tangent previous to the curve. This is my curve. If I draw a tangent line here, okay, so any tangent which is previous to the curve from here to here, that is known as my back tangent. So this is my back tangent. Okay. Second one is your forward tangent. Any tangent which is starting after the end of the curve. So this is my end of the curve here, this point. So any tangent line which is here, okay, that is called your forward tangent. So tangent following the curve is known as forward tangent. Then we have the point of intersection. If you extend this back tangent and this forward tangent in the backward direction here, Okay, you extend this here, you extend this here. So these two tangents intersect at this point. So this point is called your point of intersection. Okay. Third one is your point of curve. Point of curve means the point at which curve changes its alignment from straight to a curve. At this point, what will happen? The alignment is your state, and then we have the alignment changes to curve here. So at the point where the alignment changes from a straight to a curve, this point is called your point of curve. Or you call it as it is the beginning point of the curve. This one is the beginning point of the curve. What is point of tangency? This is my point of tangency. The point at which the curve changes its alignment from a circular curve to a straight curve. So at this point, we have meet. This is the last point of the curve, or you call it as it is the end point of the curve. So always this is denoted by T1. That is point of curve is always denoted by T1. Point of tangency is always denoted by T2. Okay, just remember it, T1 and T2. Like, next is your angle of intersection. Now, this is my back tangent, if you extend it here, if this is my forward tangent, if you extend it here, the angle here, the interior angle between the two tangents is called angle of intersection theta. So this is angle of intersection. Clear? Now, this is my exterior angle, this one. This is my back tangent, okay, and this is my forward tangent. So this angle, which is nothing but your exterior angle, that is called your deflection angle or deviation angle. So this is called your deflection angle. That is the exterior angle between the two tangents. Clear? Next is again tangent length. Tangent length we also call it a tangent distance. So tangent length is the distance from the point T1 to the point of intersection. So this is my tangent length from here to here. Okay. Similarly, in a simple circular curve, the length from point of intersection to the point of tangency T2 is also called your tangent length. So this is also tangent. This is also tangent length. This is also tangent. And for simple circular curve, both these tangent lengths are equal. Okay. Next is what is external distance E. External distance E is the distance between the midpoint of the curve. This is my midpoint of the curve, that is point C here, and this one is your point of intersection I. So the distance from I to C, this is called your external distance from here to here. Next is your length of curve. It is always noted by small l. Okay. So length of curve is nothing but your curve distance from point T1 to point T2. Or you call it as it is the center line distance along the length of the curve from here to here. Clear? That is the curve distance between point of curve and point of tangency. Next is long chord. If you join this point T1 and the point T2 along a chord here, so this is my shorter distance. Okay, so this distance, that is the chord distance from T1 to T2, this is called your long chord, and it is denoted by capital L. Mid-ordinate. If you bisect this long chord, so this bisection point is at D, and the midpoint of the curve is C. So the distance from midpoint of the long chord to the highest point on the curve is called your mid-ordinate. So the distance CD is called your mid-ordinate. Then we have normal chord, which is always noted by small c. Okay. So what is a normal chord? Now, generally, you know that the tape is either of 20 meter of length or 30 meter of length. Okay. So if you start from here, okay. So if you are using 20 meter chain, so suppose that this is my 0 here, then 20 meter, then 40 meter, then 60 meter, and so on. Okay. But when the curve is started, it is started, the chainage or the distance is started from the straight road from this side. Okay. So if you are counting the distance from here to here, it is not necessary that it will always start from T1 at 0 tape length. So 0 end of the tape is here. But somewhere, suppose that the full length of the tape is here. So only this much length is left here. Okay. And the next full 20 meter of the tape comes out to be here. So what will happen? The first chord, if you join T1 is your first point on the curve, and the full tape length will be somewhere here. Okay. So the first chord, this is if you join it from here to here, that is called your chord. Subchord. This is called your subchord. So this always less than the tape length, that is 20 meter or the 30 meter. Because why? Because you're measuring the distance from the back side. So it is not necessary that full chain length will be at 20 meter. Clear? So the first chord is called your normal chord, and it is always less than the tape length. If you are using 30 meter tape, then it is always less than 30 meter. If it is 20 meter, then it is always less than the 30 meter. So first chord and the last chord here, okay, it is always less than the tape length. So such chords are called your, such chords are called your subchords. That is denoted by C dash. So first chord here and the last chord here, whose the distance is less than, always less than 20 meter or 30 meter, these are called your subchord. And the chord between all these chords, between this point here and this point here, okay, these are all your either 20 meter or 30 meter. So these are called your normal chords. Normal chord is always noted by C, and subchord always noted by C dash. Just remember that the first chord and the last chords are subchords, and all other chords in between the first chord and the last chords are normal chords. What is right hand curve? If you are doing the survey in this direction, okay, and your curve is deflecting towards right of you. So this is my, and now here the curve is deflecting toward the right. So this is called your right hand curve. If the curve is deflecting towards left, suppose that the curve is going this way on the left side, then it is called your left hand curve. Clear? Now come to the various formulas for elements of simple circular curve. The first formula is length of curve. How to calculate this length of curve from here to here? Okay. So that is length of curve is always denoted by small l. Okay. The formula for this one, this is nothing but your arc length. So arc length is, as you know, this is equal to radius multiplied by this angle here, total angle. Okay. So this total angle is how much? This is delta by 2 here, delta by 2 here. So total angle is delta. Why it is delta? Deflection angle here is my delta. So the angle, the deflection angle is same as that angle which subtend at the center. So this total angle is again delta. So the arc length, that is your length of curve, L is equal to radius times this angle, central angle. So radius times delta. Okay. Now you have to convert this because this delta is in degrees. You have to convert into radians. So this is equal to R into delta into, you have to convert this into radians. So pi upon 180 degree. Okay. So this L comes out to pi R delta or 180 degree. So this is my formula for calculating the length of curve. R is radius and delta is the deflection angle here. See? Where R is radius, delta is the deflection angle in degrees. Okay. Next formula is tangent length. How to calculate this length from here to here? That is called your tangent length, and it is denoted by capital T. Okay. So this T is equal to, if you consider this triangle from here to here. Okay. This is again right angle triangle. This is my hypotenuse. This is my perpendicular. This is my base. Okay. I want this perpendicular here. So perpendicular from base is nothing but tan theta, tan delta. Okay. So this is perpendicular is equal to how much? This is my R. Okay. So this is equal to R tan of delta by 2. Okay. R tan of delta by 2. This tangent length from here to here, this is nothing but T1V. So T1, in some books it is written by V, or in some books it is written by I here. Okay. So both are same. T1V, this tangent length from here to here, this is equal to T2I or T2V. Okay. So this is equal to, this is my T, capital T is equal to, this is my R from here to here. So R tan of delta by 2. So this is the formula for calculating the tangent. Next is, we have the long chord. Long chord means from here to here. Clear? So this is denoted by capital L. So this L is equal to T1 D T2. So this is equal to twice of, because this is a midpoint, so twice of T1 D. from here to here. Now consider this triangle. Again, this is a right angle triangle. You have to apply simple trigonometry here and calculate the value of what is T1D. Here. So this from triangle OT1D, sine of delta by 2 is equal to T1D divided by R. Okay, so we have to apply the sine theta formula. Okay, so this is equal to T1D is how much is equal to R sine of delta by 2. Okay, so this upon this is nothing but your sine theta or sine delta. Okay, so this is equal to R sine delta by 2. Just multiply it by 2 to get the total length. That is L is equal to twice times of this one. So twice R sine of delta by 2. Next is apex distance E. So this is the distance from here to here. That is called apex distance. Always noted by capital E. So this is equal to this either IC or VC. So this is VC is equal to how much? From here to here, this is VO. If you subtract from this VO, if you subtract this CO, which is nothing but your R, okay, then you get this distance from here to here. That is called your apex distance. So this is equal to, just apply the using this triangle, okay, apply the trigonometry, that is your R sec delta by 2 minus R. Take R outside, so R sec delta by 2 minus 2. This is the formula for T. Then we have mid-ordinate. Mid-ordinate is this one. It is noted by either capital M or in some books it is noted by OO. Okay, so this is OO is how much? This is equal to CD here. So which is equal to CO minus DO. CO is nothing but your R and DO is nothing but R cos of delta by 2. So just take out outside R 1 minus cos of delta by 2. So in this way, by applying the simple trigonometry here in this figure, we have to calculate various distances. Next is designation of curve. How the curves are designated. The sharpness of the curve is designated either by its radius or degree of curvature. Okay. Now this radius is adopted in UK and the degree of curvature is adopted in USA and India. So if you define any curve that is either designated either by its radius of the curve or by degree of the curve. Degree means the angle subtended at the center of the curve. So what is your arc definition? Arc definition means the degree of the curve will be defined as the angle subtended by an arc of 30 meter or 20 meter length at the center of the curve, generally used in highway practice. If you take an arc, suppose that if you take an arc, suppose that this is my arc here, okay, one arc. The arc is 30 meter or suppose that 20 meter. So this arc, how much angle it subtend at the center here, okay? How much angle subtended in the center, that is called your arc definition. So this arc definition generally used in highway practice. When you are designing the highway curves, we are going for arc definition. What is chord definition? Chord definition means, suppose that if it is my arc is here, okay, and the chord is here. This is my arc, okay, here, and we have a chord here. So if the chord is 30 meter or 20 meter length, this chord, how much is subtend at the angle at the center? Okay, that is called your chord definition, and it is generally used in railway practice. So I will show you in the next slide how it is used. Okay. In actual practice, every curve is chosen so that either its radius or its degree is expressed in round numbers. So there is a common practice that radius is always in round numbers, like suppose that 100 meter, 200 meter, 300 meter, not fraction of this. Okay. Similarly, we have degree of curve like 3 degree, 5 degree, 8 degree curves, whole numbers. Now look here. Suppose that I just explain it again. Suppose that this is my arc here, from here to here. Suppose that this arc is 30 meter. So how much this arc subtend at the angle, subtend an angle at the center, that is called your arc. Okay. If suppose that this is my chord from here to here, this chord is suppose that 30 meter long. How much this chord subtend at angle at the center, so that is called your chord definition. So this is the meaning. Okay. Now suppose that by considering the arc definition, if R is the radius of the curve, this is my radius of the curve, okay, and D its degree. D is your degree here. Okay, the angle subtending at the center for a 30-meter arc. Suppose that this is my 30 meter from here to here. So what will happen? Now R into D is this one. If you multiply this R into D and you convert this into radians because it is circular angle. So multiply it by pi by 180 degree. So this is nothing but equal to, according to arc definition, this is equal to 30 meter here. This is equal to 30. So what we will do? R is equal to, just solve it. So 30 into 180 divided by pi d. So finally it will comes out to be 1719 over 2. So this is the relation between the arc and the degree of the curve. If you suppose that you are having some degree, you are given some degree in the problem. Okay. So just use this relation, you will find the radius of the curve. Okay. Suppose the degree of the curve is given to you as 5 degree. So just put it 5 here, you will find the radius of the curve. Now, if R is the radius of the curve and D its degree for a 20 meter arc. Now, this is the formula for 30 meter. Now, if your curve is your 20 meter of arc, so what is the formula now? Now, R into delta into pi over 180 is equal to 20. So just solve it. You will get this R is equal to 1146 over T. So you have two formula. If you are plotting the curve with the help of 30 meter tape, then use this formula. If you are plotting the curve or design the curve using a 20 meter arc or 20 meter tape, then use this formula. Okay. Now, degree of railway curves. What the code says, the degree of railway curves is varying from 1 degree to 6 degree. Any value from here to here for railway curves. For highway curves, we are using a higher value, 1 degree to 20 degree. Clear? So just put the values here, D here, you will find the radius of the curve. So that's all about the degree of the arc definition. Same formula is applicable if you are considering this by calculating this by the chord definition, then you also get the same formula between the radius and the degree of the curve. So this is all about the theory of the curves. Okay. So next time we will discuss how to lay out these curves. Layout means how to actually trace these curves. If you have a certain data on your paper, how to trace these curves actually on the ground, on which a highway or a railway curve is established actually in the field. So that is called your layout of the curves. So next time we'll discuss various methods of layout of the curves. Okay, how to set out the points, how to lay out the points actually in the field on which you have to trace your curve. Okay, so that's all for today's lecture. Next time we'll discuss the layout of the curves. Thank you.